Hello everybody. This moment I will be demonstrating to you a numerical method which is used in getting the values of unknown variables in a system of linear equations, which is called the gauss-seidel method. So for example, we have 2x plus 4y plus z equals 13, x plus 2y plus 5z equals 20, and 7x plus 3y plus 3z is equal to 22. Now, for this given of system of linear equation, the value of x, y, and z are equal to 1, 2, and 3 respectively. So in gauss-seidel method, the first thing you need to do is to make sure that the diagonal of your system of linear equation will become dominant in magnitude compared to the other two variables. So what do I mean by that? So you need to make arrangement of these equations so that your values on the diagonal will become dominant. So the one that will be placed on the top of our equations will be the third equation. So 7x plus 3y plus 3z equals 22. And then the next one is our first equation, which is 2x plus 4y plus z equal to 13. Then the next one will be the last one. So x plus 2y plus 5z equals 20. So as you can see, 7, 4, and 5 here are dominant in magnitude compared to the other numerical coefficient sum. For 7 is greater than the sum of 3 and 3, while 4 here is greater than the numerical coefficient sum of 1 and 2. Now for 5, it is greater than 1 plus 2. So after arranging them to get a diagonally dominant numerical coefficients, we need to have our guess for the values of x, y, and z. So for now, let's make the value of x be equal to 0, the value of y be 1, and the value of 2, z be 2. Now let's proceed for getting the iterative solution for every variable. Now for our x, we will be using the first equation. So for getting the value of x, we know that we are just going to simply transpose the other two variables there and divide all by the numerical coefficient of x. So it will be 22 minus 3y minus 3z all over 7. And for y, we're going to use the second equation, which will be 13 minus 2x minus z all over 4. Now for our z, it will be 20 minus x minus 2y all over 5. Now, let's proceed to our first iteration. So, using the first initial guesses of x, y, and z, which is 0, 1, and 2, we're going to solve for the value of x. Now, x will become 22 minus 3y minus 3z all over 7, which will become 22 minus 3 times the value of y, which is 1, minus 3 the value of z, which is 2, all over 7. Now we will get 1.8571. Now let's proceed in getting the new value of y. So for getting the new value of y, we will be getting or substituting the updated values of our x, y, and z. So for now, our y will become 13 minus 2 times x, which is our updated 1.8571, not the last guess, which is 0. So 1.8571 minus 3 times z, which is still 2, all over 4. What we will get here will be 1.82145. Now for our z, again we will be using the updated values of x and y. So 20 minus x, which will be 1.8571, sorry for that, and then minus 1.82145, which will be divided by 5, obtaining value of 2.9. So as you can see, the value of x, y, and z here are yet to approach the values of 1, 2, and 3. No matter how large it is in the first iteration, after getting the values of x, y, and z in the other iterations or more iterations, we will get a more precise value of x, y, and z, which will eventually become 1, 2, and 3. So let's proceed. Let's try for the second iteration. Now our x will become 22 minus our updated value of x will, for y is 1.82145 minus 3 times the updated value of z, which is 2.9, all over 7. Now what we will get here is 1.1194. As you can see, it's really approaching the value of 1. Then our y will be 13 minus 2 times x, which is 1.1194, minus z, which is 2.9, updated value, all over 4. So our value will be 1.9653. As you can see, it's also approaching the value of 2. And for z, it will be 20 minus 1.1194, which is our x, minus 2 times 1.9653, all over 5. Now the value of that will be 2.99. Again, as you can see, it really is approaching the value of 3. So for iterations 3, 4, and 5, we will be approaching the values of 1, 2, and 3 for our x, y, and z. So that's all for now. That is gaussseidel, and I hope you enjoy my presentation. That's all. Thank you.